class, I'm going to help you with number 3 in exercise 8. Number 3 in exercise 8. So we have our translation. You only have this, but it needs to turn into this. So when you're doing this, you have to be careful for everything. Conjunctions, negations, conclusional statements. Read it even a couple times and just take your time with it. And you might have to do some labeling. So if you do need to label. And let's just label it real quick. If a composition has both meter, which is M, and rhyme, you might be asking, Mr. Steinbeck, how do you know what to label? Sometimes it's fairly obvious, sometimes it's not. That might sound subjective, but right now, I know that I have a if statement, which is a then statement, and that's going to come into play in a minute, but wrapped up in the if statement is the logical operator and, or conjunction. I got meter and rhyme. Meter and rhyme, which is what you see down here. So M and R, then, that concludes it. This is kind of, actually not concluding it, but it's about to conclude it, is a poem, which is where I get my P. So the if statement is actually this whole section in parentheses. And my then statement is the P. Let's keep moving. I got a negation. What am I negating? It is not the case. It is not the case that this composition has meter or rhyme. There's my M and R again. M and R. M and R. This is how we'll be doing it if you kind of need a little extra help. And I have a logical operator or, which is my disjunction. Notice though, there's a negation on the outside and it's negating both of these. So my parentheses covers them both, and this negation on the outside negates both of them. How do you know that? Because the negation is first. It is not the case that this composition has meter or rhyme. Both meter or rhyme is negated by the sheer fact that the not is on the outside of it. And then once I'm finished with that, therefore, which is what we see right here, this composition is not a poem. Here's my P. Negation P, not poem. Okay, a little bit extra talk, but hope you're picking up what I'm putting down. It is okay to go this slow. It'll make you a better logistician. I think that's the word. Is that the word? Logician? Logician. Let's go with that. Moving on. Once you got them down there, I put my line under here. Whoa, get it together. It's a funky line. I got my line there. And remember what I'm doing. Lesson 8 starts short of truth tables. I want to declare that this is invalid. In order for it to be invalid, my premises, which is how many? 2 of them. You might be thinking, how is that possible? I see so many logical operators. Well, remember that this M and R, it's really the if statement. And here's the then statement. So really, your logical operator that you want to focus on or label as a truth is this one. Is that one. For this one, I'm negating this premises. I'm negating this premises, this supremise. So the truth value is going to go under here. If it's an invalid statement, or invalid argument, both premises must be true, and my conclusion must be false. Put the false under the negation. Stay in order there. So I fill in what I don't know with what I know. I know that negation P is false, so the opposite of that, the true value, or the opposite value of P, is, well, all right. Less talking, Mr. Steinbeck, and more writing, huh? Yeah, that sounds good to me. This is false, all right? You get the point. So P anywhere else? Yep, right here. I will put truth right there, my T right there. I know that both M and R are negated. Both M and R are negated. Right? Right. So this is a false. And that's a false. Okay? And if I know that M is false here, M is false there. If I know that R is false here, R is false there. All right, I've filled in what I need to know. Now I need to find out if I have some contradictions or not contradictions. For my disjunction, in order for it to be true, then I need to have at least one truth value. But there's no truth values. So that's a false. That's a false. Okay, let's move on here. And this is good. So nothing wrong right there. Actually, well, I'll come back to it. I'm working here now. For M and R to be true, or for this logical operator conjunction, in order for it to be true, both propositions need to be true. Is that the case? No, it's not the case. It's false, which is okay. And remember that this is the real one I want to focus on when it comes to this guy. For the logical operator, conditional, in order for it to be true, well, in order for it to be false, I need the antecedent to be true, the consequent to be false. Anything else is true. So I have a truth value, and this is false. Bring this down just to help myself visualize it, and that's true. And you know what? That's good, because it's not that guy. So that's good right there. No problems. My assumption was accurate in that premise.